located right here in our nation's capital, which has been offering support for the growth of the American Math movement. The American Math movement is a grassroots movement supported by the American Math Parent Teacher Support Group, which you are invited to become a member of. All you have to do to become a member of the American Math Support Group is to join us weekly as we come together as parents and passionate educators committed to improving the math performance and academic outcomes for our learners. The first episode of the American Math Parent Support Group is us just introducing American Math, telling a little bit about the history, and inviting participants to ask any questions that they might have pertaining to American Math. American Math is based off of a pragmatic approach to mathematics outside of traditional test scores, but more committed to improving pragmatic, applicable math performance in the real world. This country was built centuries prior to the introduction of standardized tests, and we're committed to revisiting what made America the nation that led the world into the Industrial Revolution. So we're going to start off with a little bit about myself. My name is Nkosi, and I am a stay-at-home dad that began to commit my life towards improving math education for our community, considering something that here in America is called the achievement gap, where there was a disparity in math performance between members of my community as opposed to math performance in other communities. And I was taught by my elders and my parents that if you have a problem in your community, it's your responsibility as a man to take on that problem and solve it. If there's disparity, crying will not change it. Complaining will not change it. So I was taught to not complain, but to compete. So I embraced that challenge and committed to improving math education for first and foremost my children, and then growing out from that to my community. I have traveled internationally from Washington, D.C. to Florida, as well as to Africa, to do research on improving math performance for our community. And then I realized that America has a very rich history that's deeply rooted in some very amazing math systems that are modern. Some are modern and some are even ancient. So that being our introduction, I'd like to just jump right in. Our goal is to, with this organization, to create what we call the American Math Movement. The American Math Movement is, again, a grassroots organization committed to improving academic performance for our learners here in America, but also international citizens. We encourage you to follow our movement at American Math Movement, or hashtag American Math Movement, and also follow us on social media at American Math. And the goal of this movement is to give parents and educators control over math education. The United States of America has made some tremendous changes in math education in the past decade. This is actually the 10th year anniversary of the implementation of standards here in the United States of America through Common Core. And a lot of parents and educators feel as if their agency and involvement with the introduction of those standards excluded their voice. And American Math and the American Math Movement is committed to recognizing the voice of parents and educators and making sure that they're leading the way when it comes to the scientific research and development of the American Math program. American Math is trademarked, it's proprietary, and this organization, for those who just joined us, The American Math Movement is brought to you, or brought to us, by a learning institution here in Washington, D.C. called the Benjamin Banneker Institute for Technology, Research, Innovation, and Creativity. It is the official organization responsible for the scientific research and development of the American math system. So with that said, I like anyone who's interested, because we have a lot of different parents from a lot of different age groups, who, if anyone has any questions, first and foremost about the American Math Movement, and then secondly, if you have any questions about math education that you would like us to address, please put your question, the grade level, and any of your concerns in the chat, if you could, if you have any questions. If you like to just open up on your mic and ask a question, that's fine as well.
Okay, I have a question. What is exactly Common Core math? We hear that a lot in schools, in the public school system. So what is that exactly?
Okay, that's very good question. So Common Core is a federal rollout of a list of milestones that are expected to be learned throughout the entire country based on grade level. What brought Common Core into existence was the establishment of two major global international standardized tests. One of those tests are called TIMS, the acronym.
I'm over here.
If everyone could, if everybody could please mute their mics, that would be great. Okay, circling back, the Common Core system is actually the outgrowth of globalization and the establishment of international tests. There are two major international tests that take place. One is called TIMS. The acronym escapes me right now, but I think it's spelled TIMMS. And the other standardized test is called PISA. And these international tests reveal, as we go into the information age, which countries are best equipped to lead our global family into the future based on these international test scores. So America has been waning in comparison to other countries on these test scores. The leaders in the world when it comes to these test scores are largely in China, Japan, Singapore, and then when it comes to Western countries, I think Finland and other countries in Europe are leading ahead of America. And in comparison, America's test scores have been dwindling regardless of demographic for the past 50 years. So this is very concerning. So the American government looked at best practices in these other countries and realized that a lot of them they're socialist countries that are rooted in communism, which means they have one centralized system of managing their education system. America, being a democracy as well as a country of capitalists, we're a capitalistic country. We have so many different states that have their own educational curriculum that there was no consistency in standards in math education or any type of education. So you could live in, let's say, Washington, D.C., and then you move to, let's say, South Carolina. And then you just moved from the nation's capital to a different state. And that prior to Common Core, your standards and expectations were different state by state. So we're talking about America has 50 states, which will mean it's equivalent of having 50 different countries that have their own math and literacy expectation. So America saw that maybe that's why we're dwindling in comparison, because there's no continuity in our curriculums as far as a country. So America sought the need to respond hastily, and it's because there's no time to waste. We're talking about you have to make sweeping changes in a very short period of time. So there are educational institutions here in America that went abroad to Asia as well as other European countries to identify best practices. And then they brought those best practices to America. And I can go more into depth to explain that to you if you have any questions. And then they did some case studies and then a mass rollout through Common Core. And they did that about 10 years ago. And I can give you the breadcrumbs if you want to learn more about what organizations were involved and where the case study was and what the mass rollout was. So when seeing that, I was studying it the entire time. I was a math educator, a homeschool math educator prior to the implementation of Common Core. So as I watched it evolve, I started to learn the source of where this transformation was coming from. And I saw that the problem of its implementation is that they learn math methodology from other countries. They learn best practices from other countries, but they didn't tap into the math practices that already exist here in America. I think there should have been more time devoted to actually involving parents and educators with the development and rollout of our national standards. But I understand that the organizations that were in charge of its implementation had to do it with the knowledge that they had at their disposal, and they had to do it as fast as possible. So that's the root of Common Core. If anybody has any details that they want to learn more about it, please feel free to put it in the chat, or what's a good email?
Maths@gmail.com.
No, American Math email for someone.
Oh, info@americanmath.com.
Yeah, just send us a question at info@americanmath.com, or either again, look for us at social media at American Math. Are there any questions in the chat?
No, not right now.
Okay, does anybody, we're going to open it up for question and answer. Thank you so much, Alicia, Coach Alicia, for that question. Does anyone have any questions? Because this is back to school 2024. And does anybody have any questions on how to help their children when it comes to learning math? Because that's another complaint that we've received in our research, that parents don't feel that they've been given the necessary support material and resources to help their children learn math. So are there parents that, if you could put it in the chat, whether you are a homeschooler or whether you, we're going to give a quick survey. Do you homeschool, or do your child go to traditional public or private school? If you could put that information in the chat. Okay, have a homeschooler. Oh, private school. Great. Okay. What grades are you, what grades do you all supervise? We have 7th grade, 9th grade. Okay.
Okay, Miss Sakara had the question. I have a 3-year-old. Where do I go from now? Now that he knows how to count, I plan on homeschooling.
Okay, great. You're at the right place if you plan to homeschool. When you say that now he learns how to count, could you tell me Could you come on and you can speak? It's okay to now that you've posed the question. Could you open up your mic and tell me what do you mean by now he knows how to count?
Hi there.
Hi.
As he has a pretty good concept, right now, without assistance, he can get up to about 30.
Wow, that's
But
awesome.
um, I guess what I'm wondering is how do I, just keep expanding on that besides, just the counting and whatnot? What other math skills can I give him
Hmm.
at this point?
Okay, so when you say he knows how to count, could you tell me how you taught him to count?
Every day we just went back and forth, kind of like a call and response
Okay.
type thing.
Hmm.
Um, Literally every day we just went through and counted things like objects.
Perfect.
Um, he can identify like the numbers,
Hmm.
the different numbers. So we have like little the what are they called? The refrigerator magnets
Excellent.
for him to use.
Hmm.
Just every day, if not or every other day, repeating things like that.
Okay. Um, so as part of the American Math Movement, our goal is to empower parents and educators with information, encouragement, and resources, as well as support. So there's been a transformation in math education here in the United States of America. So you might want to get a notebook and jot this down, what you want to research, because my goal is to empower you as a parent. You want to research the new methodology that America is embracing. Um, it's called concrete, pictorial, and abstract. There should be some information on the internet about concrete, pictorial, and abstract. The term was coined by a Harvard. He wasn't a mathematician, but he was a Harvard professor named Jerome Bruner. Um, pull up. Can you pull up something about Jerome Bruner? Um, and he said that it's beneficial for learners to learn by first counting concrete objects, which you have definitely done the right thing by leading the way in that. Then learners should have a pictorial representation where they can look at a picture of the object or either draw a picture of the object, and then that will help them conceptualize the concrete. It's because it's very hard to draw anything that you haven't first touched or seen. And then he said, after you've learned the concrete, the pictorial, then you need to go into the more abstract. The United States of America, for the past, I'd say 100 years, we've excluded the concrete and pictorial and taught historically mathematics through simply abstract algorithms and equations. So the number 2, in and of itself, if you saw the equation 2 plus 2, it's abstract as an equation. But if you put 2 objects on a table and then you add another 2 objects to that, the first 2, then conceptually you can see that the 2 put together with 2 make 4. So the first thing I would ask you to do is first learn more about the new direction that math education is taking. It's called the concrete, pictorial, abstract approach. We've here in America, we've branched off and we've implemented our own response to that, to concrete, pictorial, abstract, that incorporates more right brain learning. So we do what's called the TDI system, which is touch, draw, and imagine. And again, we'll go more into depth with touch, draw, and imagine for those who decide to join some of our workshops or who decide that they want to make a commitment to having, a more dedicated approach when it comes to American math. But concrete, pictorial, abstract will definitely be a great jump off point to just learn it and where it comes from. But believe it or not, even though Jerome Bruner was the first to mention this process, the country that embraced it after they received their independence from the British, I think in 1969, was actually Singapore. Singapore was a colony of the British, and it did not want its independence from the British. But it came a point in its history that they received their independence, and it's a small island country, and they did not have a lot of agricultural land. They didn't have a lot of commodities that they could export. So they were trying to figure out how to move into modernity, to a modern era with the resources that they had. And they've spent a strong level of concentration into improving the knowledge system for their citizens. And then out of that grew the Singapore math system, which is largely what a lot of learning institutions in America have embraced. They've gone out to Asian countries, as I mentioned earlier, for those who are just joining us, and they've embraced best practices from other countries. But our goal is to first and foremost be aware of those best practices, which we've thoroughly researched. But we're also more concerned about the fact that American math we have our own math culture here in America that existed for thousands of years prior to, believe it or not, colonialism and the establishment of the United States of America. We're talking about America has ancient math systems that were used to build these beautiful pyramids here in America, and infrastructure and cities that existed in the pre-imperialism and pre-colonial. And we've done research that seems to indicate that there was also ancient measurement systems and math systems imported to the United States of America for the establishment of its infrastructure. So concrete pictorial abstract, research that. Tell me what you learned this upcoming week, and then we can go more into depth with it next week to give you because we're going to meet every Sunday to give you, some steps to take forward after you understand what CPA concrete pictorial abstract is. Do I have another question? I saw someone's hand was up.
Alicia had her hand raised.
Yes.
I did have a question, but when we got the slide up, that answered the question about the concrete pictorial and then the abstract.
Correct.
I watched a couple of videos, I think Thursday or Friday after we initially talked, and it was just like, wow. It was just like an aha moment. So when you have an actual book, because really schools are not, they don't teach it in this way. We jump from concrete all the way over to abstract,
Right.
Which a young child or even an older child, and we've seen the videos on TikTok where parents are yelling at the kid because what is 2 + 3, or they're not understanding that they're actually missing like one key element there. And while they're shaming them, they're creating that anxiety there.
Yes.
So then the kids, so it just made me go like, oh wow, they're missing this middle part. They need to see a representation first before they actually are understanding those symbols. 3 numbers are just symbols.
Correct. And again, I can do it. I'll put together some information this week for those who want to receive it. If you send us an email, we can also send you out some information leading up to next week about the history of this system, because the concrete pictorial abstract system is actually not new. It can be traced back to ancient civilizations. The most prominent would be ancient Egypt. where ancient Egyptians created.
Can I interrupt real quick? I'm sorry.
Sure.
We have a question in the chat from Super Savvy. He's asking, can you recommend some books on CPA?
I'm really trying to think about it. Actually, I would encourage you to, and I know this might sound a little self-promoting. I would encourage you to stay with us as far as the American math movement versus suggesting other books. And the reason that I would encourage you to do that is because even though I think Jerome Bruner is an incredible educator that's done a lot for education curriculums, and I think Singapore Math has done a great job as well, there's components missing from their program that that we've learned about and that we've built upon, which is the TDI method, which is the touch, draw, and imagine method, which incorporates right brain learning. Now, don't get me wrong. I'm not saying don't go do more research on concrete, pictorial, abstract. I will recommend a book that was put together by Singapore Math. Again, I really love what Singapore Math has done. It makes sense for Singapore, but I think it limits math education when it comes to America. So we'll put the book in the chat. It's called, I think it's called We Didn't Learn Math This Way, or We Didn't Learn Math Like This. I don't mind. Yeah, it says We Didn't Learn Math. What's the title of it?
We didn't learn math this way.
Yeah, We Didn't Learn Math This Way. Okay. It's by Singapore Math. I would encourage parents to buy that if your children are going to school in the United States of America, either as a private school student or high school student. Because what America has pretty much done is, and you'll see when you read the book, there are members of learning institutions here in the United States of America who threw their hands up and say, okay, cool, we don't have this math thing figured out, so let's go to other countries that do, and let's adopt their best practices. They chose Singapore because it's one thing to be able to adopt a foreign math system, but it's a whole different challenge to adopt it in a foreign language. So they looked at Chinese math and they looked at Japanese math first. But the challenge was curriculum developers would have to first learn to translate the curriculum from a foreign language before implementing the curriculum into the school system through mathematics. And then there's the whole issue of standardization. So that model seemed impractical. So they went with Singapore because Singapore is an English-speaking country, and they just started learning their best practices. Now, here's the challenge. The majority of the world uses the metric system. If you could please bring up the map showing how the majority of the world uses a standardized unit of measurement called it's called SI units, and it's the international system of measurement used for the majority of the world. The United States of America uses a different system. Singapore Math and the majority of our international neighbors uses the metric system. The problem with the metric system, and I don't want to get too much into math, but the metric system was implemented and introduced into Europe by the French in, I think, 1795. Okay. Prior to that, they had thousands of measurement systems throughout Europe. It was the first time that Europe had one consistent measurement system. Is that on the screen? You see, okay.
Yes, it is.
All right. So you see where it's blue? Okay, that's the metric system. This is where countries have officially adopted the metric system. Where it's red is you have United States of America, and then you also have Liberia and Myanmar. Myanmar, formerly Burma, still use what is called the imperial system. Okay. We started digging through the crates and started saying, okay, cool, why is this the case? Because there's been past efforts to introduce the metric system into the United States of America. Okay, I have a quick little fun quiz, a little challenge. Please put it in the chat. What's the oldest recognized European settlement in the United States of America? Put it in simple terms. What's the oldest city that's been established in the United States of America? Anybody? And it's okay to use the internet. This is what we want to do. The internet is a beautiful resource. What's the oldest city in the United States of America? The longest is recognized as a city in the United States of America. And there's a bonus question. Who was it founded by? You can speak up if you like. You can just speak up, open your mic, or you can put it in the chat. Again, this is our pragmatic, practical application when it comes to learning.
I looked up, okay, this is not something that I knew. St. Augustine, founded in 1565.
Correct. That is 100% correct. So can you find out who was it founded by?
Let's see. Don Pedro Menendez.
Okay, so yeah, what country? Yeah, what country was he from?
I don't see that.
Somebody help.
Help me out, people.
Yeah, this is a collaborative learning experience.
All right, go ahead.
Where does the name Menendez come from? What country does that come from?
Sounds Spanish.
You're 100% correct. So St. Augustine, Florida was actually a European settlement founded by the Spanish in 1565. So we're talking about, this is years prior to the British involvement in colonialism in the Americas. It was decades prior. And the Spaniards came here in 1565, and the Spanish, for those who study history, were also slave traders. So they would import slaves from Africa. The Portuguese and the Spaniards, I think, were some of the first to be involved. And then British caught on later. British caught on a bit ultimately later. But the Spanish and the Portuguese led the trend, and they brought over brilliant enslaved artisans, architects, engineers, craftsmen, tradespeople that have learned certain skill sets and technology for thousands of years through generational transfer of knowledge in Africa. So we're rarely taught that this is how, infrastructures were built, but you had brilliant architects and engineers that were just forced to build infrastructure for other people. So the measurement system that was used to build the infrastructure in the United States of America was a standard unit of measurement called the cubit. And if you read any ancient texts, I even believe in the Bible, the cubit is mentioned almost 300 times. And I think in the Quran, 25 to 27 times. So we're talking Old and New Testament. It's been mentioned 300 times. And even in the other Abrahamic belief system, the Quran, it's mentioned. So the cubit is a standardized unit. If you could bring up an image of the cubit, that would be great. So the cubit is a standardized unit of measurement that was used to build ancient infrastructure in Britain, and the British got the use of the cubit from the Romans, who I believe in the 1st century. I think Claudius, you do some research and check up on me. He introduced the cubit into Britain to build its ancient roads and infrastructure. So, and I think it was literally I think maybe 1,600 years prior to the British being involved with colonialism and slave trade. So the cubit measurement system was introduced into Britain in antiquity during the era of the Romans. At least a millennium prior to the British becoming imperialists. The Romans adopted the cubit from the Greeks. So when Rome took power from the Greeks, they had to use the cubit system because they were an imperialist nation, which means they went and colonized other countries and enslaved other countries, which means you have to adopt what was already there. So the Romans got it from the Greeks. The Greeks were also colonial powers, which colonized along with the Romans, colonized a great portion of northern Africa. So if you ever heard of Carthage and the Punic Wars between the Carthaginians and the Romans, that was an indigenous northern Africa where the wars took place. Once the Romans conquered Carthage, the condition of their treaty was either they were going to burn Carthage to the ground or all of the citizens of Carthage would become slaves. So the leaders of Carthage decided it's best that Carthaginians survive for future generations versus being slaughtered. So the cubit was used to build ancient Carthage. The Greeks gave it to the Romans, or the Romans adopted from the Greeks, and the Greeks again learned it from the ancient Egyptians, the ancient Nubians. And now we're doing research that shows that there are ancient stone circles that go literally from seemingly the northernmost point of Africa all the way to South Africa. I think if you look up the Golden City or the Great City of Zimbabwe, we'll come back to the cubit. If you look up the Great City of Zimbabwe, these stone circles, if you look up African stone circles, you'll see that there are ruins in Africa that are prehistoric. And there's this advanced technology that's been discovered by a South African named Michael Tillinger. And I think he's been doing research on these stone circles. And there are thousands of them, if not tens of thousands, if not hundreds of thousands. Could you enlarge that image? So when we visited Africa, we learned more about the counting system. We just learned a lot. We learned, if you've never been, it's a beautiful place, beautiful people, incredible people. So when we visited South Africa, we loved it. And we learned a lot about the culture and the cultural influence and the just the advanced excellence of the culture that predated the Ma'afa or the transatlantic slave trade by hundreds of thousands of years. So these stone circles are ruins, but they're the places that were built by the descendants of those who were exported out of Africa. So they're just left in ruins. So when we did our research, we was like, okay, well, what measurement system built ancient Africa? And then we learned that it tied back, if you can bring back the cubit, it tied back to the ancient cubit measurement system. So when you ask about studying and getting books on concrete pictorial abstract, I welcome you to. I think that's awesome to continue to study. But our research has shown us that you'll meet a wall, which is fine. You'll meet a wall where you'll realize that, okay, cool, I can learn the Singapore math system and I can learn the metric system because the majority of the world uses it, and they build their curriculum for the metric system. The qubit system, which BITRIC, for those who came in late, it's the Benjamin Banneker Institute for Technology, Research, Innovation, and Creativity. The BITRIC system is the modern qubit measurement system. Okay. So you have the metric system, which is used by the majority of the world. And then you have the BITRIC system. And the BITRIC system is the foundation of what's taught through the American math system. The reason why we teach the BITRIC system is because we have to continue the scientific research, development, and dissemination of educational information for the ancient qubit. What you see on the screen is the first standard unit of measurement in the world. It was used to build Britain. The measurement system was used to build ancient Rome. The measurement system was to build ancient Carthage. So the qubit measurement system, the vestiges of its existence is embedded within the infrastructure of the United States of America. So the only way you can learn the BITRIC measurement system and American math is here with us. So I encourage you to please embrace these modern measurement systems. Embrace the metric system. Embrace Singapore math. Eureka math, which is used largely in the United States of America, you will see is pretty much a mirror of the Singapore math method. So if you study Singapore math and you study Eureka math, your child should be good on standardized tests. They'll do better on standardized tests. If your goal is to do well on standardized tests, you will do those are a great place to start. If you want to prepare your child to enter the workforce as an American citizen, you might need to go a little further than standardized tests. Because if you do any research on our standardized test scores here in America, they've been declining steadily for well over a century. So if you want to continue to embrace the methodology of those who've gotten us to where they are, and you want to wager that outcome on the new implementation of Common Core and the standards, feel free. You have every right. Here at American Math, we want to give parents and educators more agency and more involvement by giving you the information that you need to decide, and also give you more resources and more information on how to prepare your learner to be a global citizen and an American citizen, because we have our own unique measurement system. Okay. I learned something very deep when I visited Africa. I learned that because as an African American, I was born here. I brought back my name Nkosi because it has my initials, Nkrumah Kenyatta, in the name. And I learned something that was very interesting about African culture. American culture, we have the privilege of being independent because our society supports so much for us. We have free school systems. We have an incredible infrastructure. We have all of these rights that have come from centuries of sacrifice from others who did not have them. And I learned that we have a lot of independence in the United States of America. In Africa, I learned that the society is interdependent, which there's village models, and that it matters, what family you're from and how big your family is, and societal decisions are made on what families marry each other, and it's not what class you're in many African countries. It's what caste you're in. It's what family you're in. And why I'm saying that and what the significance of that is that I learned when I was in Africa, there are people who own, thousands of acres of land. And if their family is involved in agriculture, they prepare members of their village to inherit. In African culture, it's all about inheritance. They prepare their future generations to inherit agriculture, and they have large families. So even though some might decide to go outside of agriculture, there is an institution of education that prepares someone to inherit that agricultural business. There, we had the privilege of meeting some members of the Royal Bafokeng family. The Royal Bafokeng family, they own platinum mines, and they literally build their industry around their citizens inheriting opportunities from the distribution of platinum throughout the world. Okay. So when I'm seeing I'm seeing Africans on this level, and I'm talking about it's on every level of business. I learned that education is preparation for the next generation to inherit their nation. So if you look at the world from that perspective, standardized tests start to become less significant. If you look at the world from the perspective that education, you might want to write it down, it's preparation for the next generation to inherit their nation. That visit to Africa had me come home and look at America totally different. Because America is literally the wealthiest economy in the world, with such abundance of opportunity and a free education system and high-speed internet, where if you can't get it from the school system, you can get it largely for free on the internet. And if you just create your own sovereign decision for the course of study that your child is going to take, America has more than enough resources to provide that education for your learner. And it's been earned. Okay? If your child wants to be a doctor, you can chart the course in kindergarten. If your child wants to be an entrepreneur, you can chart the course in kindergarten. If your child wants to be an architect, engineer, scientist, there are so many resources here in the United States of America for them to inherit that, for the next generation to inherit opportunities. The opportunities are abundant. So what does that have to do with math education? If education is preparation for the next generation to inherit their nation, I'm going to give you all a quick test. See if you can answer it within 15 seconds. Chime in. You don't even have to tap it in the chat. Just answer as soon as you can. How many ounces are in a cup? Count down.
Is it 16?
Anybody else want to help? Feel free to look it up
I
online.
think it's 16.
How many ounces are in a cup?
30.
Please chime in with the answer from online. Did anybody type it in the chat?
Not yet. Shakara got it. 8.
Very good. There are 8 ounces in a cup. Very good, Shakara. Here's another one. How many ounces are in a pound?
$16?
That is correct.
Way to go.
That is
Hey.
100%. That is 100% correct. Okay, here's another one. How many parts are there to an inch?
Parts?
Yes, an inch is broken into fractions of an inch. So how many fractions are there in an inch? Typically on a ruler, there's more than one answer for this, but they're all related. But there's on a ruler, how many fractions are there to an inch? Could you bring up the eye for rule, please?
16?
That is correct. Are you seeing a pattern?
Yes.
There you go. So what we've realized is that if you look at does this look familiar to anyone? Feel free to open your mic and chime in. Does this look familiar to anyone?
Yes.
What is that?
Unk. Is that the unk symbol? Or the...
It's a good guess. That's a good guess. This one's
Okay,
a little
no.
different.
Okay.
Does anybody else want to open up their mic? All right, do the units of measurement look similar or familiar?
Wait.
We're not this.
Samaria had it.
What did she write down?
Oh, she said the eye of Horus.
Correct. It's the eye of Horus, the eye of Aru. It's also called the Wajid eye. Does anything about the fractions look so familiar? So remember, use the number 16. Okay, if we just go with ounces, this is a duplicative system. It's also using our modern day computers. It's called a binary system. And our research has indicated that the ancient cubit, which we'll bring up later, it's what we call a multi-numeral or multi-base system, where we use different number systems. Okay. For simplicity's sake, if you look up different place value systems or bases, they call them base 2 and base 4. We don't call them bases or radix. We call them bitric systems. So you have, so with American math and bitric, you have to learn multiple number systems. So the majority of the world uses the metric system, which is a bitric 10 system. Okay, which means you group at 10. Your first group is at 10. It's also what's called a fixed base system or fixed place value system, which means you have 10. And then once you group at 10, you group at the next column at another group of 10, which is at 100. And then you group at a next column, which is another group of 10, which is 1,000. So that's called a fixed base or fixed place value system. The metric system is fixed. It's a fixed place value, fixed base system. It has one number system. It's 10. Okay. Okay. The ancient qubit system, which is today the modern day bitric system, used a myriad of different place value systems. Okay. So it's a way more flexible system. So again, if you want to use Eureka Math, you want to use Singapore Math, I do not consider them competition. I consider them global partners in improving math education throughout the world. It's just that they are not aware of the ancient bitric system. So they have a fixed base 10 number system. Okay. Ancient Egyptians and other ancient societies had a more flexible multi place value system, a flexible place value system where numerous number systems were used interchangeably. And it's evident with our current measurement system here in the United States of America. So getting back to ounces, if you look here, that's half an ounce. Then if you double it, that's an ounce. I'm gonna say that's a quarter. I'm sorry. Let me
See
say
half it.
if you well, let's do it this way. Let's not look at it as a fraction. Let's invert it so it's 2/1 instead of 1/2, because ancient Egyptians used unit fractions. So instead of looking at that as 1/2, let's look at it as 2, and then you double it, and then it's 4. And then if you double that, it's 8 ounces. And then if you double that, it's technical difficulties. There we go. Were we back up and at it? Okay, cool. So then, so 2 ounces double to 4 ounces double to 8 ounces. 8 ounces is a cup, doubles. And if you double 8 ounces, you double to 16 ounces. Well, that's a pint. And if you double the 16 ounces, you have 32 ounces, which is a quart. And if you double the 32 ounces, you have 64 ounces, which is a half a gallon. And if you double half a gallon, you have 128 ounces, which is a gallon. So the United States of America uses this ancient measurement system. It uses the ancient cubit. That's why the Bitric system, which is, again, a mixed place value system and a mixed number base system, is more flexible and has advantages to people who live in America that you can't find outside of America. You can't learn the Bitric system anywhere else but from Bitric. So we'll be teaching learners the learning system that's applicable to become an American citizen. That's why American math was established, so that Americans can learn their own number and measurement system. Do we have any questions?
Now, well, I have a quick question. As far as the symbols where we have our senses, right? Smell, sight, thought, hearing, taste, touch.
Mm-hmm.
Now, I was told once before, which I thought it was a great idea, when teaching children, we should use or stimulate their senses while learning.
Okay.
Do you think that is the reason? I mean, what is this concept?
Okay, so and I think that warrants investigation or research. It's just not our focus. A lot of people, when it comes to the ancient Kemetic and ancient Egyptian system, they tend to want to learn more about the esoteric, and our concentration has been strictly pragmatic and practical use. So our research doesn't involve much when it comes to actually learning the more esoteric components of Egyptian math. We focus primarily just on the math component. So we would love to devote some time and interest into that, but I think that's more advanced to get. And I think future researchers at Bitric can delve deeper into that. But our concentration at this time is primarily the pragmatic applicable function when it comes to mathematics. Does anybody have any specific questions about math education? Because you joined us, I just want to know, I just need you to chime in why you joined, what you were hoping to find, and how we can help you on your journey as a parent and educator.
I will just chime in again. The reason why I came is because I am always looking for different ways to teach math.
Okay.
I am doing homeschool this year, so it can be challenging because I will have to do research so I can actually quickly understand a concept so I can then, teach my daughter. A lot of times parents, are doing math homework with their children in the evening, and we a lot of times don't understand what
Okay.
we're actually teaching, especially when, kids get in the upper grades.
Okay, great. So we'll be opening up workshops. The American Math Movement and the American Math Parent Teacher Support Group, which you all are participating in, this is open to anyone who would like to be a part of the movement. But what we are going to offer, or we're going to offer workshops, and we're going to offer other courses of study and intensives that gives more concentration to specific learning concepts. And we'll open those up for those who first attend the American Math Parent Teacher Support Group. This is our first meeting, and we have to consider that, we have varying age groups, and we have varying, we have varying goals and objectives for each parent and teacher. So we have to make sure that we open up the workshops and the courses according to the needs of the participants. But I appreciate your participation and your enthusiasm, and I will discuss some things offline that I can definitely send you to help prepare you as a homeschool parent. And please invite other people who participate. It doesn't have to be homeschool, but other people who are on a learning journey similar to yours, just dedicated parents who are committed to providing the best education for their learners. And we'll create courses that can help you on that journey. We'll spell it out for you. We'll share our terminology, our methodology, our best practices. One thing that I will say that that I think is a different about our system is that, again, we learned in Africa that ancient Africans had a game-based approach to math education. We learned about this game. They have things called traditional games in Africa. There's this ancient African math game called Diketo. I don't know if people remember the game Jacks. Do you remember playing Jacks, Generation X? If you could bring up a video on Diketo. Jacks were actually based off of an ancient African game called Diketo. Diketo requires tremendous hand-eye coordination, where you learn your math facts by playing a fun and engaging game. Another game that's very common throughout Africa, we recognize it today as Mancala, but in antiquity it was called, and it's called different names throughout all of Africa, but it's recognized as the oldest board game on Earth, and it's largely played throughout the entire continent. Now today it's only recognized by modern scholars as a board game, but in antiquity it was used as an abacus. And we'll bring up a video for us to watch as we close, to give you more insight into that. So we'll try to find a Diketo.
Spell it.
Diketo.
Spelling it wrong.
Yeah. Requires I'll let you all watch. Can you all hear?